Good morning, everybody. Now, in yesterday's video, we talked about the lengths when intersecting chords or secants inside the circle, the lengths of those chords. Today, we're going to talk about when they intersect outside the circle. So we're talking about type 2 and type 2 and type 3. Now, when we talk about this, this is going to be the outside times the whole thing. So the outside, so A, times the whole thing, which is A plus B. So that'll be the first part. That will be the same as C, and if we add these together, this will be C plus D. This will be the same for every type of problem like this anytime that you see the two segments intersecting outside the circle. Now it's going to be the same for type 3 when we talk about a secant and a tangent that intersect outside the circle. It's going to be the outside times the whole thing equals the outside times the whole thing. Now the outside and the whole thing are the same exact here, so that's why I get A times A, which this is switched to A squared equals B times B plus C. Now we're going through some examples on this. It is not hard. I think you'll be okay. We just have to start paying a little bit closer attention to our algebra when we do these. And flip down here. Let's look at number 5. Now, a couple things we need to know. We know this whole length is going to be x plus 9, and this whole length is 8 plus 19, or 27. So it's going to be the outside times the whole thing equals the outside times the whole thing, the whole length. Hopefully that kind of makes sense. I'm going to be repeating it over and over and over again. What we'll have here, we're going to have 8 times 27. 8 times 27 is 216. I'll have 9 x plus 81 when we distribute. I'm going to bring the 81 over here. 216 minus 81. Oops, cord got in the way there. 135 equals 9x. X will be, if I take 135 divided by 9, x will be 15, which is what we had to answer there. Okay? Hopefully that made a little bit of sense there. Number 6 is very, very similar, so we can go over that one real quick. It won't take that long at all. So again, we got to find the whole length. 42 and 10 is 52, so we have 10 times 52 is equal to 13 times 13 plus x, or x plus 13. 10 times 52, hopefully don't need our calculator, it'll be 520. 13x plus 169 when we do that there. So I'm going to bring the 169 over to the other side. So 520 minus 169 is 351 equals 13x. I'm going to divide that by 13. I'll get x is equal to 27. But please pay attention. We have to find the length of NL. So if this is 27, 27 plus 13 will equal 40. Okay? So again, if you wanted to check that, we take 13 times 40. Oops, not 41 times 40. Oops, let's try it again. It's 520. And then 10 times 52 is also 520. That's a way to check your answer. Make sure you're correct. Okay? All right, so if we take a look at, what happened there? Here we go. If we take a look at number 7, again, we're going to have to go through the same process. This whole length will be 3x plus 12. 8 and 4 is 12. And this length here will be 5x plus 9. So again, it's going to be the same type of equation. The outside times the whole thing is equal to the outside times the whole thing. Do some distributing here. 24x plus 96 is equal to 35x plus 63. Now there are more x's on the left side, sorry, on the right side. So move this 24x over here, move this over here. 96 minus 63 is going to be 33. Oops. And 35x, so 35 minus 24 will be 11x, which means x, if we do some math, will equal 3. Okay, so we've done some of those now where we have two secants cutting through. Now let's look at number 9 where it's got a secant and a tangent. Again, we are going to have to find this length. This whole length here will be x plus 18. So the outside times the whole thing for up here will equal the outside times the whole thing. Now 24 times 24 is going to be 576. Will equal 18x plus, and then 18 times 18 we need to distribute. Will be 324. I'm going to bring the number over here, so 324 I'm going to bring here. 576 minus 324 is 252, is going to be equal to 18x. So 252 divided by 18 is going to be 14. Okay, we'll do one more, maybe a couple more, we'll see. Okay, let's take a look at number 11. This is going to be a little bit different, but I think we'll be okay. Still have to find the whole length. 27 and 21 is going to be 48. So x outside times the whole thing for here, outside times the whole length will equal outside times the whole length. This turns into x squared. 27 times 48 is going to be 1296. Now we are going to have to take the square root of 1296. So second x squared, 1296. That'll be 36. We have that there. Now remember, it will be plus or minus 36 if you look at it. Doing your math, when you take the square root of a number, a negative times a negative is a positive times a positive, so you do have to be careful. But in this case, because x is a length, x has to be positive, so keep that in mind. Okay, let's take a look at one more here. I see number 12, I think is going to be a fun one. Okay, if we do this here, we're going to take the outside times the whole length. 9 and 16 gives you 25 equals outside times all things. So this will be 9x squared is equal to 9 times 25. 9 times 25 is 225. Before I solve, remember you have to divide by 9. So if I take 225 divided by 9, you'll get 25. Which means x will equal a positive or a negative 5, but again, I'm only going to choose a positive because x is part of a length. Okay, so that covers our segment lengths if they intersect inside the circle or outside the circle. Keep in mind, if they intersect inside the circle, you are multiplying the parts. If they intersect outside the circle, it's outside times the whole thing equals outside times the whole thing. I hope you guys are all doing well. And if you have any questions, please leave them in the comments below or email me personally. Have a great day.